All right, let's shift gears. Suppose it's not plus, suppose it's times. Well, let's first look at this cosine function. I'm actually going to do this one in black, it makes it a little bit easier. If I just put in cosine x here, and if I put in 0, of course I get 1. Okay, I'm going to put pi over 2, 3 pi over 2. Okay, if I put in pi over 2, well, cosine of pi over 2 is the x value when we rotate around the unit circle, right? We rotate around the unit circle to pi over 2. The x value is 0. So pi over 2, I get 0, and we get here. And if we continue on this, we put pi, we get negative 1. And if I get 3 pi over 2, I get back to 0. And then at 2 pi, and 2 pi, I get back to 1. Now that's the standard cosine function. But what happens if I want to look at this blue one, y equals 4 cosine x? Well, how does that change things? If I write 4 cosine x, what I'm doing is I'm multiplying each of these outputs by what? By 4. I'm taking this guy and multiplying by 4. Well, multiply this by 4, you get 4, 0, negative 4, 0, and 4. Well, what's that do to it? Well, instead of me having this point, I'll have 0, 4 right there. That's the blue guy. And if I go pi over 2, I'll get 0. Okay, right there. And if I get pi, I'll get negative 4. That's down here. And if I put 3 pi over 2, I'll get 0. And if I put 2 pi, I'll get 4. 2 pi, I'll get 4. Well, what did that do to it? That vertically stretched this function. Okay, that vertically stretched this function. So now the cosine function, think of it being stretched and pulled vertically. What it did is it stretched it and made it larger vertically. So when we have a number like 4, what it does is it stretches it vertically. But what happens if we had a number like, say, 1/2? Okay, maybe I want to graph, say, y equals 1/2 cosine x. Well, instead of stretching it vertically, it's actually going to compress it vertically. So I'm going to put in here, I'm running out of room here. Let me erase this one and just put it here. 1/2 cosine x. Well, let's see what this one looks like. So I just take a half of this, and I get a half, 0, negative 1/2, 0, 1/2. And now I get something that looks like this. 0, 1/2, pi over 2, 0, pi, negative 1/2, right? Oops, pi, negative 1/2, 3 pi over 2, 0, and 2 pi, 1/2. So that vertically compressed this mamma jamma, didn't it? Okay. So we have two things going on here. Number one, if we add a number to a function, it shifts it up or down. If we multiply a number by our function, our trigonometric function, it stretches it vertically or compresses it vertically, depending on whether the number is bigger than 1. If it's bigger than 1, okay, then it's going to, the absolute value is bigger than 1, it's going to stretch it. Okay, if it's absolute value that is less than 1, well, it's going to make it compressed vertically. Okay, now we're going to do more on transformations. We looked at shifting it vertically, up and down, and we looked at vertically stretching and compressing it. Now we're going to look at some horizontal stretches and compressions. So let's take a look at that. Now notice the difference here. This is inside the argument here. Okay, this is inside the argument. This 2 is not being multiplied on the outside. Okay, it's on the inside. But it's very important. It's a very important distinction. Okay, so what's happening here when I graph my cosine function here? Well, let's talk about what happens if I do this. What does this do? Okay, so let's go through the drill here. Suppose I put in 0. Okay, what's cosine of 0? Well, cosine of 0 is the x value at the terminal point. Right here, if I have 0, there's my terminal point. What's the x value? Well, it's 1. So I know that in my normal cosine function, okay, it looks something like this. But this is not cosine. This is cosine of 2x. However, in this case, if I put in 0, cosine of 2 times 0, you have to do the 2 times 0 first, you get 0. So cosine of 0 is still 1. So in this case, actually I should put that in blue. That that's still 1. So I'm going to graph that, and I'm going to put that right here. Okay? Now, I'm actually going to, instead of, the last couple ones I've been putting pi over 2, pi, 3 pi over 2, 2 pi. I'm going to change it up this time, you'll see why. The next one I'm going to put in is pi over 4. Okay? Well, what's cosine of pi over 4? Well, cosine of pi over 4 is root 2 over 2. Okay? Excuse me. Okay, so excuse me, I'm allergic to math. Cosine of pi over 4 is root 2 over 2. But if I put pi over 4 in here, what's 2 times pi over 4? 2 times pi over 4 is actually pi over 2. So in this case, I'm looking for cosine of pi over 2. What is cosine of pi over 2? That is, what's the x value of the terminal point of pi over 2? Well, my x value is 0. So, oops, wrong color. So at pi over 4 is approximately right here. Notice that I have 0 as part of my graph. 0, 1 is one of my points. Pi over 4, 0 is one of my points. Okay? Now we'll do pi over 2. And we know normally that cosine of pi over 2 is 0. We get that. But now let's check it out. What's cosine of 2 times pi over 2? 2 times pi over 2. 2 times pi over 2 is pi. So what's cosine of pi? That's the x value at my terminal point right here. What's the x value? Well, that's -1. Okay, so I'm going to put -1 there. So at pi over 2, which is this location, right, half of pi, I've got an output of -1. I think you probably can see what's happening here. If I put in 3 pi over 4, right, that's 3 pi over 4. Normally cosine of 3 pi over 2 is negative 2 root 2. Or, sorry, negative root 2 over 2. But if I do 2 times 3 pi over 4, 2 times the x value is 3 pi over 2. So what's cosine of 3 pi over 2? Well, cosine of 3 pi over 2 is 0 again. And we're talking about the terminal point at when the t value is 3 pi over 2. What's the x value? Well, it's 0. So now I'm back to here. And then the last one is pi. And we know that cosine of pi is normally -1. However, we want cosine of not pi, but cosine of 2 times what x is. X is pi, 2 pi. Cosine of 2 pi. What's the x value here? Well, it's 1. And so now you'll notice that this is the full period of the cosine curve, but not done in 2 pi, but done in pi. And notice that we can just repeat this over the next period of pi, and so forth. Copy and paste, copy and paste, copy and paste, over and over and over. So what this 2 did inside here is it actually shrank it. It horizontally compressed us by a factor of 1/2. Okay? And I think you can probably guess what happens when I do the sine function. Well, if I do the sine function, you go through the same steps. Instead of having the normal sine function, which completes its full period in 0 to 2 pi, well now, instead of doing it 0 to 2 pi, I'm stretching it out horizontally. So now my full period is 4 pi, and it should look something like this. Okay? So, when I have a number larger than 1, it's a compression by a factor of 1 over it. And when I have a number smaller than 1, it's a stretch, a horizontal stretch of 1 over this. So 1 over 1/2 is 2. Okay, so let's look at this in general. So we have the sine and cosine curves. If we have y equals a sine of kx or y equals a cosine of kx, both of those have amplitude absolute value of a, and they have period 2 pi over k, where k is greater than 0. Okay, let's put it together and make sense out of it. I know that's a lot of mathy stuff, so let's figure out what it means. Let's take a look at this example here. The first thing I want to identify is what A is and what K is. So you'll note that the absolute value of the amplitude is the absolute value of 3, which is 3. Now what that tells me is that this function is going to be 3 high and 3 low. Okay, that's what it tells me. So I'm going to stretch it a factor of 3, right? Vertically. Now, I also want to find out what K is. Well, K is equal to 4. So this function has period 2 pi over 4. So 2 pi over 4 reduces to pi over 2, which means the whole function, the whole cosine function can be graphed. Cosine function looks something like this, right? Okay, cosine function looks something like this. The whole cosine function can be graphed in a period of pi over 2. So pi over 2, it's all going to get done. The whole period is going to get done in pi over 2. Okay, now what's in the middle here? Well, in the middle of 0 and pi over 2 is pi over 4, correct? Okay, and what's in the middle of each of these? Well, if this is pi over 4, okay, which is the same thing as 2 pi over 8. This will be pi over 8. And this will be 3 pi over 8. Okay? So, let's graph the whole thing in 0 to pi over 2. We're going to graph the whole thing, the cosine function. So what's the cosine function look like? Well, it looks like this. Oop, I missed it. There we go. And that's actually right there with the lowest it gets. Did the whole graph in 0 to pi over 2. It's that simple, okay? How high and low does it get? What's the period? Good, period's 2 pi over this number, 2 pi over 4, pi over 2, the whole thing's done in here. Got to draw the whole cosine function. Cosine function looks like this, good. And it's got to start at here. It's going to go through each of those points. Fantastic. Okay, now we're going to talk about this one here. Y equals negative 1/2 sine of 1/3 x. First thing we need to know is what's the amplitude, okay? The amplitude is the absolute value of negative 1/2, which is equal to 1/2. So the maximum this thing's ever going to get is 1/2. The smallest this thing's ever going to get is negative 1/2. Okay? This negative is going to play a component. What negative does to it is it flips it with respect to the x-axis. And so that's going to come to play. We also want to know the period. Well, the period is 2 pi over k. In this case, k is 1/3. Well, 2 pi divided by 1/3 turns out to be 6 pi. So this whole thing's going to be done in 6 pi. So that's half of 6 pi, and then half of 3 pi is going to be 3 pi over 2. And that's 3 pi over 2, right? This is going to be 6 pi over 2, correct? And so then that's going to be 9 pi over 2. Then we're going to graph the sine function all in this. Now the normal sine function looks like a nice little roller coaster that starts going up. But because it's negative, instead of starting going up and then down, I'm actually going to start down and then go up. And so our graph is actually, since it's negative, the negative amplitude does that to it. So my graph looks, oops, got a little funky there. Looks something like that. There we go. Again, the negative makes it start downwards. It flips it with respect to the x-axis. Boom, I flip it.